College Street and Yonge Street. Actually, it's about 4 doors from Yonge Street. It was the, I forget the name of it now, regulatory body for natural gas. And they had like a chairman, you know, these are typical political appointees, and they might have had 10 staff. And every year these guys, in those days it was consumer gas, would have to bring them their cost data and their price data, and they would go through it and they would figure out the regulatory price. That's what they do. That's what they did, right? Still do it in certain things. Now, in this type of monopoly, our issue is always to minimize efficiency loss. And ideally, we'd like zero efficiency loss. So therefore, what price should we force this monopoly to sell at? To minimize efficiency loss. What price? To give zero efficiency loss, what price do we want? Yeah. Yeah, or better to say P equals MC. Better, I only say better to say that because the rule is P equals MC and competition satisfies that rule, right? But the rule is P equals MC, but you're right, competitive equilibrium price. So P equals MC. So the monopoly, the regulatory agency says, okay, there's your data, you guys have to produce right here. And forces them to produce here, right? This is what the monopoly produces. Now my question to you is, can the monopoly produce there? It turns out they can. Because look, at this output, they've got carte blanche from the government. They can do this, they've been regulated, great. But you'll notice, they have an economic profit. Not as large as their other one, but plenty large. So acceptable to them. Really acceptable. This is how you regulate the typical monopoly. All right? Good. Now we're going to wake these suckers up. Next, get out your pads of paper and be ready to go. Okay, this could be a diagram on your exam, 10 marks. Here we go. This is a diagram of a natural monopoly. Show monopoly equilibrium, price, and quantity, and economic profit or loss for 5 marks. Let's do it. Yes. Can you repeat the question? Yeah, this will be a diagram that you'll see at the exam possibly. This is, by the way, the hardest of them. Interestingly, more students burn on this one than anything else. They shouldn't, of course, but they do. And it's simply, for 5 marks, I want you to show me monopoly equilibrium output and price and economic profit or loss. Okay?
For natural monopoly?
Just for whatever that is on the board. You're looking at the demand function and the average cost function. That's the average cost function of that monopoly. How do you know that's a natural monopoly, by the way?
Minimum of the average cost curve is to the right.
Yeah, the minimum of the average cost is to the right. Another way of expressing natural monopoly is they can satisfy all of demand at a falling price. You could have the minimum to the left and it would still more or less dominate a market. But we're going to leave that alone for the moment. Just use this. This is our natural monopoly. So one thing to remember is a natural monopoly usually has huge fixed costs. Like, as I say, Bell Telephone. They have telephone wires, telephone poles, transformers, and the like all over the city. Can you imagine if every individual phone company, had their own telephone poles, telephone wires? Ridiculous, wouldn't work. Or what about gas companies? If we had competition with gas and they were all having their own pipelines. Ridiculous, right? Or water, or whatever. But the point, so they have very large fixed costs, and not very large. Their marginal costs therefore tend to be fairly constant. So although you can draw this like this, I wouldn't recommend it. Better to do, let's see, you could draw a marginal cost kind of like this, showing it kind of going up through that minimum somehow. I can't do it easily. Maybe we can. Like this, right? This could be the marginal cost function. But I typically draw it like this, because for most of its range, it is in fact constant in practice, say up about there. And then the last little bit, it's easier for you to do this than me on this thing here. Right? There it is, marginal cost. And then marginal revenue. And then the output of profit maximization for the monopolist, MC equals R, and then the price. So EM, QM, and this happens to be marginal revenue. All right, and the economic profit and loss, here's the average cost at that output, and the difference between the average cost and the price is that. Okay? Good. Now show me what the optimal allocation of resources is, the price and quantity at the optimal allocation of resources. Again, just the formula, boom, find it. What's the formula? Huh? P equals MC, right? So therefore, since marginal cost is constant here, it may not be your case, but I'll call this P star. I'll actually call it PMC, so you recognize that's marginal cost pricing. And over here, QMC, where marginal cost intersects demand. Don't be sloppy. It's easy to get the wrong intersection if you're not thinking. For example, to get this one or something else. Make sure it's MC, QM. Okay, now, therefore, what is the efficiency loss? People just watched. I want you to draw it for the moment, but you could. The efficiency loss is the difference between this zero efficiency loss, what society is willing to pay measured by the demand function, up to monopoly equilibrium, and above marginal cost. There's the efficiency loss to society. Everybody? Okay, now you've got about 7 marks. Next, how are we going to regulate these guys? Can we have this monopoly? Can we tell this monopoly they must sell at a price that equals marginal cost? Look at it. Can this monopoly literally sell at a price that equals marginal cost and be a private monopoly? Go ahead, why not? Yeah.
Because it's already selling below that price. Well, I mean, in other words, if it raised its price to competitive equilibrium, then it wouldn't. I
think you're right. I'm just going to focus you here.
Okay.
If it sold at this price, what would happen? If this was the price it sold at, it sold this amount at this price, what would be the problem? Look at it closely. Yes. You make an economic loss, everybody. Make an economic loss. Notice. Be ready to identify it if I need, if I ask you to. There's the average cost at this price. Right? There is the economic loss. In fact, what you're looking at there is basically the fixed cost. The marginal cost is not covering the fixed cost because it's so close, it's so constant. Right? Now here we have this situation. And the problem really is a problem dealing with short-run marginal cost in a lot of modern economics. This, like the debate went on, and really we should be using long-run marginal cost. But notice, this is the most efficient firm we could have on earth. In this one industry, it is the most efficient firm. It produces cheaper than anybody else. And it cannot produce at marginal cost pricing because there'll be an economic loss. Can't do it. Right? So basically, you've got a choice. You know, and the competitive firms, remember this firm is the optimally sized firm. The competitive firms might look like this. I'm making them even, you know, they wouldn't necessarily look like this. There's one of them, right? That's the other firms in the industry. They can't compete with this thing. And even if they could produce, for example, like this, then this firm just lowers the price to say here, blows these guys out, and comes back and operates like this. No competitive firm can compete with this thing. And in general, it can produce, not always, but in general, if it wants to, it can produce cheaper than the competitive market price, because there's more, you know, most firms are not optimally sized, at a greater output, and still make an economic profit. In short, it's flat out more efficient than a competitive firm. But our theory, P equals MC, leads to a oddity because we interpret it as in the short run. Don't you worry, this is just the way we do it. So, I mean, it's a problem, but we don't need to worry about it. Okay, so it turns out that's not going to work. This is the only firm in the industry. It's sure as heck not going to operate with an economic loss. So, what do we need to do? We need to get that private firm to operate at the nearest price to zero efficiency loss. And what price would that be? Would it be this price? 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 What is the price that will keep this firm in the industry still operating and make it as close as possible to zero efficiency loss? Yes? Price equals AC, right? So this is called average cost pricing. Right here. This kind of monopoly, a natural monopoly, is regulated by average cost pricing. PAC. QAC. Right? And that's how, for example, Bell is, you know, Bell owns the transmission lines. Didn't know how to control monopolies at a certain point. They want competition, i.e. they want marginal cost pricing, but you can't do that with the natural monopoly because the fixed cost isn't covered by the marginal cost, or price of marginal cost as it is normally. So what do? Like 20 years ago, people finally figured out, hey, wait a minute, what we're going to do is we're going to allow Bell to be a monopoly. It owns all of the lines, the telephone lines. We're going to allow Enbridge to own the pipelines. But they get to charge people to use their pipeline like a transportation network. So if some other person wants to sell gas, they have the right to use the pipeline of Enbridge, and Enbridge has the right to charge them a fee which is set like this, average cost pricing. And then there's competition in the sale of gasoline separately from the use of the pipeline or the telephone lines, right? So that's what happens. So this is called average cost pricing. Now it turns out, just to point things out to you guys just very briefly, this is like a nuclear power plant. Because usually, in most regions where they exist, you know, like think of Darlington, just outside Toronto. That nuclear power plant supports, you know, gives most of the energy to Toronto, most of the electricity to Toronto. It's big enough to do all that. It's hugely expensive. You could have it as a monopoly, and this is the price that it would charge, right here. And in fact, that's what happened in the US. And their rates used to be like 15 cents a kilowatt in many states in the US, California in particular. Or you could have it regulated, which doesn't usually happen in the US, and force them to charge PAC, which might be 6 cents a kilowatt. Or you could do the Ontario solution, which is what? Which was what? It's not quite the same now. But 10 years ago, what was the Ontario solution? Do we have a private monopoly operating, providing energy, electricity in Ontario? Yes or no? Don't you guys know this? What is the biggest, it used to be the biggest, I don't know, by far the biggest firm in Ontario? biggest producer in Ontario. Do you know what that is? Huge corporation. Yeah,
Maybe Ontario Hydro.
Ontario Hydro. Huge, massive corporation. It had like, well, I'm not going to go into, there's so many things. Anyway, Ontario Hydro was set up in 1906, and its motto is this: power at cost. It produces power at average cost pricing, has for 100 years. And Ontario, for 100 years, up until 20 years ago, had basically the cheapest power in North America. Pretty, and significantly lower than Buffalo. Which means, if you do almost anything requiring a lot of electricity, Ontario is your place. Why would you pay 12 cents in New York state when you can do it in Ontario for 6 cents, right? We had a tremendous advantage. But our conservative government of Mike Harris in the 1990s looked like, again, this is the kind of thing where somebody learned something, but not very much. And they learned this rule, because the rule was that in California, they had private monopolies, and they said, we've got to have competition. We've got to have competition. So we've got to be able to bring in electricity from any state. Well, actually, Ontario pretty well can't bring in electricity from anywhere cheaper than Ontario to produce it. Maybe Quebec, but otherwise not. So anyway, Mike Harris wanted to break up Ontario Hydro, and they tried and have it operate at marginal cost pricing. Well, you people can see right here, it can't operate at marginal cost pricing. A nuclear power plant can't operate at marginal cost pricing because of the economic laws. So he constantly tried. I was doing like a project with some people on the same thing. And they would say, he would go to the finance department and say, oh, this is the Ontario government, say, show me the numbers that show we should sell this thing. And they would come back and say, there's no way you can sell this thing. It's the cheapest producer, and nonetheless, it's producing huge profits. Ontario, in Ontario, is the cheapest producer. You can't sell it. And he would go away for a month, and he'd come back and say, do it again, I want to sell this thing. Literally. Go back and look back through the newspapers, literally. He didn't ultimately sell it all, but he broke parts of it up. So you can read that whole history, it's all fascinating. And the problem came from a stupid application of the rule P equals MC. All right? Okay, good. You're not free yet. You're almost there yet. Next, we'll do this one. Okay, here's another one. I'll do it quickly. This is the 401 versus the 407. Marginal cost is constant, but greater than 0. For the moment, just watch me do this, but I'll just do it. You would be given this sort of a thing where average cost is still falling. Hang on. Like this, all right? Now just that's the name, so on. Okay, good. This is average cost. How do you deal with this? You draw a constant marginal cost like this. Yes or no? Is that possible? Yes or no? Because some of you are going to do it on the exam. I want to know. Yes or no?
No.
Why not? It has to go through the minimum. It cannot be that. If you do something like this, that's not what we want. But at least it's hitting what you might perceive to be the minimum. It turns out it's not. But just stick it in the middle there somewhere. Okay, that'll do it. That's marginal cost. Then marginal revenue, like that. Then output. Then price. So you have PM, QM, like that. Of course, the economic profit and loss, I'll show it to you, but we won't worry about it. Well, let's just put it in right there. Okay, good. Now, an example of this is a highway, right? The 407, the 401. We can build the 407. Now, of course, there's a problem. Again, this was the Harris government. They didn't want the taxpayers of Ontario to pay for the highway. They wanted the users of the highway to pay for the highway. So what they did is, this is what the real oddity is, they built the highway and sold it to a company that operates it as a monopoly and charges that price to go on the 407. Now, my suggestion to you, then I will ask you, what should be the price charged for the 401 to give us, or that highway, to give us the optimal allocation of resources? You would look at this and say, it should be P equals MC. Therefore, this is the price that you should charge for a highway. And there would be this number of people, using the highway right here. So this would be right there, optimal number, QMC, right? This is what should be the optimal use of the highway according to marginal cost pricing. Because again, notice, up until this point, a car using the highway is willing to pay more. It's worth more to them than the cost of the car. Past this point, it costs more for the car than the person in the car is willing to pay. So this is the optimal point. That would give us, if we're interested, we kind of are, the efficiency loss due to monopoly would be like this. All right? We're going to line it for a moment. Okay, so now I say to you, can this thing operate? Could you have the 401? We could have a toll on the 401, or we could say that the private company has to charge this price. Can the private company charge this price? Yes or no? Can they or not? Tell me, you're going to shake your head. Go ahead, why not?
It's under average cost.
Yes. The private company, if this was the 407, they cannot charge this price because they would have an economic loss and they wouldn't operate. Again, as I say, why would a monopoly accept an economic loss? It would be ridiculous, and particularly a very efficient one. So, they wouldn't do that. That's not going to happen. The government could do that. They could operate a toll booth, charge this price, give that optimal allocation. But of course, then this part here, which is the fixed cost, would have to be covered by taxpayer repairs. Maybe they don't want to do that. What would you recommend? What would you recommend would be the toll charged on the 407? I'm asking you, what would you recommend? What is the toll that should be charged by the 407? People at the back there, what do you think? You know the answer. What should be? Yeah, go ahead. Go ahead.
Price equals average cost.
Price equals average cost, everybody? So, we don't, I don't know if Ontario never had this, but the New York freeway was like this for many years, way before you guys were born. But basically, you had to pay a toll, and it was owned by the government, and the toll covered the costs, average cost, right? So this was this price. If we're going to regulate the monopoly, we're going to have, in this case, this would be average cost pricing. The monopoly should be regulated into charging this price. Or the government should charge this toll by running. Either one will do. Okay, notice, what is the economic profit and loss right here? We've got another 2 minutes. Pull it together. What is the economic profit and loss here? 0. But that's not the important thing. That's just a bias line. This still has, as you notice, a significant inefficiency. Make sure you can identify. All right. So those are different options. The private monopoly, the average cost pricing where costs are covered, the optimal allocation but can only be done by government with taxes covering the rest, or we have the 401. On this diagram, I want you to tell me what is the number of cars who use the 401. If this was a highway and it's free, like the 401, what is the number of cars that use the highway? Can you identify them? You're on a roll, go for it. So again, notice everybody just by the by. When the 401 is free, it means the price is 0, right? When the price is 0, you just find out the amount of cars that are on that highway is 0. And because the price is zero, there isn't an infinite number of people who use the highway. Doesn't matter. At zero, only so many people use the highway, right? And it's this many people right here. Watch this because you'll probably see it maybe in the final exam when I need to wake you up. This would be the output of 401, or Q at free, right? This is P free. Now this requires a little thought. What's the efficiency loss at this point? Right here. Could you tell me the efficiency loss for the 401? Question for you. Is it this triangle? Well, look at it closely. This triangle, this is the difference between 0 and what people would pay for it. But what is 0? We want the difference between marginal cost and price. We want this triangle. So the 401 has this economic efficiency, plus the problem, of course, that the government has to cover the cost through taxation. So just now, and then there's a fourth diagram of marginal cost at 0. You can do that yourselves. These diagrams, this diagram alone is fascinating. You know, if we had the time, we could just stop and say, okay, guys, let's talk government policy using this diagram. It clarifies things enormously. What's at issue, what we ought to do, blah, 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 right? So make sure you can do this stuff. It's very practical, very important. Oh, and now, the moment we've all been waiting for,